Hi everyone, and welcome to the sixth part of our tutorial series tyFLOW for ARCHVIZ. In this one, I would like to show you how you can create something like these pillows and actually cloud inflation in general using tyFLOW in 3ds Max. Let's go and jump into 3ds Max and start creating those things. Here I have a bench, and we're going to start creating the mat first. So I'm going to just draw a box here, set it maybe to 65 to 50 and then 5 centimeters. We don't have any faces and segments right now going on this. It's just all one face everywhere. Then I'm gonna bring it up here and bring it close to my bench, but I don't want it to touch it actually. I just want it to be as close as possible. So let's go here, something like this should actually do the job. So they shouldn't touch each other. So you have a gap between them here. We go to the left view and see where it sits. So let me drag it back a little bit like this. And in the top view, we go and center it. It is actually in the center. So now we need some buttons on top of it in order to create those bumps. So for this, I'm going to create a small geosphere. Maybe set the radius to 1.5 or something. 0.5 here. Then go and set it to hemisphere and scale it down so it is kind of a flat button like this. And we're gonna go and align it with that box that we just created as our mat. So let me go and drag it up. And here is the same thing. We don't want them to touch. We want a gap to be between them. So just a small one, not too crazy. Now with that said, I can go and, well, first of all, rename it to buttons, and then I'm going and add an array modifier to this guy. Set that to center. Set the amount, I don't know, maybe to 15 or so. And then change the spacing. Could actually have 20 of them. Something like this. And set the Y amount to 6 and give that a little bit of spacing as well. You can have more or less or something else, but this is what I'm going to use as those buttons. So we call that rectangle mat, so we know what we are doing. And now I'm going to add tyFLOW to my scene. We go and center this, go to these settings, and here in time step, I'm going to change this to 1/6. And I'm going to add a chamfer modifier to my box as well, just in order to round all these corners and bring up the amount to maybe 2. Now select tyFLOW again, open the editor. Here we go and start with the birth object. Go and pick our mat, and I'm gonna go and add cloth bind into my event, so it turns it to a cloth. But as you can see, we don't have enough meshes and segments, so we need a really dense mesh in order to make it work really good. So for this, we're going to use the subdivide modifier or operator, and add it into our event. Go to the settings and activate relative to scale so it will evenly distribute or subdivide all the faces, and set the edge length to 1. So we really need a dense mesh here. Now I'm going to drag out a surface test because I want to bind this guy, the mat, to the buttons. So I'm going here and pick the buttons here, and down in the distance test, change it to 0.5 maybe. Let me change this guy to red. So if any particle is closer than 0.5 centimeters to these buttons, it will get sent to the next event. And here we're gonna go and deactivate it. So just drop in particle switch, make sure it is set to deactivate bindings. And we go and also add an object bind into our event. And we're gonna pick our buttons again. So it will bind all these red dots to our buttons. We also need a collision operator, and we're going to select the button and the bench as our collider object. And here again, I want also to bind my mat to the bench when it is close enough to that surface. So going back to surface test, pick the bench, and here in my object bind, I'm gonna pick the bench as well. So whenever that particles are getting closer than 0.5 centimeters to the buttons or to the bench, they will get bind to them. So they will not move anymore, they will get fixed, so they're not sliding, etc. Let me just uncheck display here and get rid of the wireframes so we see better what's going on. So you see now these red dots here, maybe I should make them a little bit larger so you can see them better. So there we go. Now we have some red dots here on the bottom and some red around those buttons. And this is exactly what we need. So now the next thing would be particle physics. Because we are not using CUDA, we're going to use particle physics to create some sort of self-collision effect here. Even it is not necessary in this case, but I'm going to show you how to do that. So we go to absolute as collider radius and set that maybe to 0.3 or something, so it's not that big. And then go down, activate ignore binding neighbors and ignore starting penetration, so it is not getting deformed right from the beginning. Now we need a force operator. Here we're going to set the gravity strength to minus 0.1. That's actually good enough. I just want to prevent it from floating around, because if you don't have that, that will happen. And this is actually what we need so far. So now in order to inflate it, we have to add a modified binding here. Go to the timing, set the timing to continuous. Then scroll down to modify bindings and go to inflation and set this guy to 1.5 maybe. That will inflate the mesh. So when we go and simulate this, let's see what we get. And there we go. This is now done. So when I move my CTI, you see what happens. Now with that said, I don't want it to be animated and stuff, so I want to have just a mat like this. So I can go and add an edit poly on top of it, right click, and then collapse to. So it will kill the entire tyFLOW setup. So this is the last step you're going to do when you are happy with your results. I'm going to call it good and then collapse it. Now I can go and delete the mat that I created before, just the box that I had, and now call this guy mat. Now I'm going to select the buttons and link him to this mat. So wherever I'm going to move this guy, those things will follow. So I'm going to center the pivot point, and now when I move it, the buttons will come with it. So that is the first part. And now we're going to go and create the pillows. For this, I'm going to use a pillow from the Cosmos library. I'm going to just select this blue one, drag it to my scene, and then go and place it. So we turn that 90 degrees, bring it up, push it back a bit. Here I'm going to center the pivot point as well. Align it to world, go to my display settings, show whole mesh, edit poly, right click, collapse to. And this is the pillow number 1. So now we're going to go and move it back a little bit with a good distance to this back wall here. And I'm going to move this guy a little bit to the back as well, so we don't have a big gap between the back wall and the mat. So something like this. There we go. Let's create another tyFLOW and go to the settings, to time step, make it 1/8. Open the editor. Now object, birth object, and then pick the pillow. Let's go to cloth bind. We set that back to 0 so it's not calculating the whole time. Then I'm gonna go and add a force operator, and of course we need the modify binding so we can inflate it. Timing again to continuous, and here inflation, let me go to 1.5 as well. I'm gonna leave everything else as default for now. Let me get rid of the display. Now we need collision. I'm gonna pick my mat as the collision object and the bench. And the next thing we need is particle physics. Set that to absolute and change it to 0.3. Now we can go down here, ignore binding and ignore first or starting penetration. So now we can go to force, give it some gravity, and then when we go and simulate this, that's what we have. But as you can see, now it is just bouncing around and doing weird things. Here in the back, it is sticking to the wall, and etc. So we have to fix stuff. First of all, I'm gonna bring it a little bit forward so it is away from this wall for now. And then I'm gonna go and rotate it this way so it is turning or facing the back wall here. Drag it a little bit more away from the wall. So now let's go and simulate it again. Okay, So it is not sticking to the wall anymore, but it is now bouncing and stuff. So we have to add a slow operator into our event. So it will slow down simulation and it is preventing them from bouncing that much. I also go to my collision and bring up the friction percentage. So I'm going to set it to 90 or something. So it is not sliding too much. So when we go and simulate it now, it should stay in place more than before, but it will still slide away as soon as it is on this mat here. We'll see in a second what happens. There we go. Now it is sliding and then falling down. So I don't want that to happen. I want that thing to be fixed as soon as it hits this mat. And this seems to be on frame 25. So we're gonna bind this to the mat as soon as it is close enough to it, and we're gonna bind it just over 2 or 3 frames or so. So in order to do that, let's go and drag out a surface test and select the mat. Go to timing, set it to frame, and change it from frame 25 to frame 26. Maybe we have to change it later on, but I guess that will work. So on frame 25, it will get all the particles which are closer than 0.5, let's say, centimeters to this mat. They will get sent to this event again, so to the new event, and we're going to use object bind and particle switch. So we deactivate the particles and we're going to bind them to the mat and make sure lock to surface is also checked. So now when we go and simulate it, it will hit the mat and get bind to it, so it will not slide anymore and stay in place, and it should actually fall backwards towards the back wall that we have. And that is actually what I'm looking for. So as you can see, these red dots here are now bind to this mat, so it is not bumping and jumping, and it is not falling down as it did before, and now it goes back to this wall because we had that rotation giving to it. There we go. Now it sticks here and stays in place. So I want it to fall back, so let me go to the first thing here and rotate it a little bit more. Maybe that helps. We go to the top view and bring it a little bit closer here. Oh, that's too close. Something like this. And give it another run. So let's check that again. There we go. Now, if you wanted to get less inflated, you have just to change this amount here. Let's go and set that to 0.8 maybe, and then wait for it. It is calculating down here because I'm at frame 69, so it will take a while. That is what we get. So that is now less inflated. It is less stiff, if you wish, and it deforms differently when you change those values. You can also go and change other values like shear and stretch and everything. So just play around with them and tweak them to your needs and see what happens. So there is nothing you can do wrong, to be honest. So here you have the shear amount. If you select the cloth binding, you have the shear amount, the bend amount, and etc. So let's bring that maybe to, I don't know, 0.3. Set that to 0.3 as well. Now go to frame 0 again. and run the simulation. So that has to do with deformation and stuff. So you can really change those amounts and see what happens. And once your simulation is done, you can actually stop it at any given point and then just go from there, just freeze it where you see that it is the one shape you want, for example. So when I go and stop it here, I want that shape, I just freeze it here. So I'm just going here and then select my tyFLOW, add an edit poly to this. We can go and select the whole element and then detach that from the rest as a clone. So just OK. Now when I go and turn off my tyFLOW, I still have this pillow here. Now I can go and center the pivot point and move that around. So this is my first one. And I can come to my tyFLOW again, move the CTI, and this is the second one, let's say. So you can go again into that, select this, detach it, and then as a clone, there we go. We can remove this. Then we have the number 2. So again, center pivot and move it around. So that is one way to create multiple pillows or whatever shape you have. The other thing is you can just take your pillow and clone it a couple times like this, and then select the new clones, go to the tyFLOW setup, add all of them to your list, and then when you go and activate it, so we go and turn on tyFLOW, turn off this pillow, we have these 4. Now we can go and simulate all together, and there you have it. So these are now 4 pillows that are animated, simulated here. And as I said, you can really go and change more or less all the parameters here in your cloth bind, so you can play around with the shear bending and all these settings here. In your modifier, you can change the inflation amount to get different results, and you can actually have different setups for each single pillow, so they are not looking all the same, and they are not using all the same forces and everything. So you have really possibilities to get some variety out of your setup. So let's call that OK for now. So I'm gonna add an edit poly to this, and then collapse 2, and call these pillows, and get rid of the original ones. So now I have the pillows here. I'm gonna go and center the pivot point to them, and this is actually it. Another thing I would like to show you is how to attach a balloon or something here into that bench. So for this, we're gonna go and create another geosphere and bring it up. We go and solo this, set it in the center for now. I'm gonna go to the top view, add an edit poly to this one, select the top and the bottom vertex, go to the front view and deselect the top one, and then here in the soft selection, go to use soft selection, activate it, and change the fluff to something like that, so the upper edge or part is not covered with that mesh, or is not affected by the fall off, and then drag that down a little bit so we have a nice balloony shape. So maybe this is just too big for now. It's smaller. So let me unsolo this and bring that somewhere here. Go to the top view, move it around that corner. So I'm gonna bring it up a little bit. Add tyFLOW. Go to the settings and change the time step to 1/6. Open the editor, Earth Objects, pick our balloon. Here we need cloth bind again and modify binding. Set the timing to continuous and go down to the modify binding settings and set the inflation to 1. Then I'm gonna add a select operator here and go and select that very bottom vertex. So it is a white dot here. I hope you can see that. And if that is not activated, just activate send out and then send that out to a new event. From here, we're going to send it out again using a spawn operator. And in our third event, I'm going to set or add a spread operator and bring down my dot, which is this guy. Let me go and make that bigger so we can see what is going on here. It is this one, that purple dot that you can see. I'm gonna bring that down until I reach the surface of my bench. So it is here. There we go. Now, the next thing is binding them together. So particle bind, add it just underneath of the spread operator. And scroll down, uncheck enable proximity bind. Go to family bind and check bind to parent. And if you show bindings, this is what you should get. So you have a line connecting the balloon with the bench, or with that particle actually, not with the bench yet. So after this, we need to resample particles. And I'm going to use the particle binding for that. So it will give me some particles between those two that we spawned and spread it. And we need a force. I'm going to set it to minus 0.5. In my first event where the balloon is, I'm going to add another force as well and set this guy to plus 0.1. So a positive value that will drag the balloon upwards and will not fall down. The amount of the mesh that we have is not enough. So I'm going to add a subdivide operator here and activate relative to scale and change this guy maybe to 1 or 2. So we have enough meshes to work with, or enough polygons to deform. So the rope, which is, or the string, which is created here, we can't render it yet. So what we see is just the binding. So if I go and uncheck this, you don't see anything here. So we need spline path operator, and then we have to create a new one that will create a tySpline here in your list or one in your scene. And here we have to use the particle binding and not the trajectory. So change it to particle bindings. And in the tySpline settings, go to tySpline, make sure weld bindings is activated, then go to the tySpline measure, activate this eye so you can see what is going on, so you see your string here and you can render it. And then in the radius settings you can just change it to 0.15 or something, so whatever you want. Then we don't have to display the dots now, so this is what you see. Me change it to 0.1, so even a little bit thinner. In the force settings for our string, I'm gonna go down to the strength amount and change it to 0.1. Frequency, I'm gonna set it to 0.02, and the scaling, I'm gonna change it to 5. And the same thing goes for the balloon itself. So select force in our first event, go down, strength set at 2.3 maybe, frequency 0.02, and scaling maybe 9. So that is for the noise and forces, so it will wobble around a little bit. Now we have to add slow operator in the first event, so it is not going too crazy. And in our rope event or string event, event number 3 here, we would go and bind that string to the bench. So for this, we're going to drag out a surface test, go and pick the bench, set the distance to something like 0.5, and then we're going to send everything which is closer than 0.5 centimeters to this bench. We're going to send it to the next event. There we go and add a particle switch, deactivate bindings, add another object bind into our event here, select the bench, and make sure lock to surface is activated. Now our string is bind to this bench, so it is not flying away. So let's go and simulate this and see what we got so far. There we go. Now we have to change the playback to real time to see what really goes on, what is the real speed. And yeah, that goes a little bit crazy. I guess we have to bring down the amount of noise for the balloon down a little bit, so 0.01 maybe, and then the scale to 6. And I'm gonna subdivide it even more, set it to 1, so it will get deformed a little bit more. So let's see what we get. Now I have to switch back to normal, so not real time. So we go frame by frame. And that looks better now, so it is not going that crazy, so to the right or left or whatever, but it moves slightly. So this is how we can create or attach a balloon to something if you want to. There we go. Now you can select this and add a relax modifier to this guy. And smooth it out a little bit. Here is a little gap between the balloon and the string. So we have to go back to the tyFLOW setup and just copy this spline path and paste it in the spawn event as well. So just paste it as an instance, and that should go and take care of the bindings here. So it is calculating that again. Let me just wait for it. And there we go. So now everything is connected. And this is actually it. That is the way how you can inflate meshes using tyFLOW and the cloth simulation or operators. And I hope that this tutorial is helpful and useful to you guys. And I'm gonna see you in the next one. Have a great and successful time. Bye bye.